Hey guys, I am Princess May Fernando of Group 3 and my topic for today's presentation is about the inductive reasoning. So first, let us define the inductive reasoning, or the type of reasoning that forms a conclusion based on the examination of specific example. Then we have the conjecture, which is the conclusion formed by using the inductive reasoning, since it may or may not be correct. Okay, so first we have the first example. In the use of inductive reasoning, let us predict the next number in each of the following lists. Sa letter A, we have the 3, 6, 9, 12, and 15. So, understandable naman na ang kasunod niya ay 18 since ang dinagdag natin bawat number ay 3. Then, sa letter B, we have the 1, 3, 6, 10, and 15. So, sa inductive reasoning kasi medyo tricky yung mga questions niya or yung kasunod na number. So, ang ginawa ko dito is find the difference or minus ko lang. So, 15 minus 10, that is 5. 10 minus 6, that is 4. 6 minus 3, that is 3. And 3 minus 1 is 2. So, nalaman natin dito na yung pag-minus ko is 5 hanggang 2. So, since yung sa 15 is 5 siya kanina, alam natin ang kasunod niya na yan is dinagdagan ng 6. So, 15 plus 6, that is 21. So, 1, 3, 6, 10, 15, and 21. Okay, so let's proceed sa example number 2. So, in the use of inductive reasoning, let us make a conjecture. Okay, so consider the following procedure. Pick a number, multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract to 3. So, any random numbers or several different numbers. Sa solution natin, suppose we pick 5, yung 5, original number natin is 5. Then, gawin lang natin yung procedure, multiply by 8, add to 6, divided by 2, and subtract to 3. That will give us the final answer of 20. So, dito sa part na to, di ba kanina, kung 5 yung kanina, what if kung 6 naman yung original number natin? That will give us the final result of 24. Then, kung 7 naman, 28. Then, tuloy-kituloy lang yan. 28, 32, 36. Then, kapag 10 procedures naman, ang final result naman niya is 40. Hanggat kapag nag-abot ka ng 100, ang final result niya is 400. So, in each of these cases, the resulting number is 4 times than the original number. Now, we conjecture that following the given procedure produces a number that is 4 times the original number. So, yun yung ating conjecture or yung solution natin. Next, we have the example number 3. So, in the use of inductive reasoning, we are going to solve an application. So, as you can see, I provided a table. Let us use that table or the data in the table and inductive reasoning to answer each of the following questions. So, letter A, we have, if a pendulum has a length of 49 units, what is its period? And letter B, if the length of a pendulum is quadrupled, what happens to its period? So, sa left side, that is length of pendulum. And sa right side, that is period of pendulum in heartbeats. So, dito naman makikita natin, bawat period ng pendulum, ang bawat length ng pendulum ay square root ng period of pendulum. So, sa letter A, ang question dyan, ano yung period kapag 49 ang units. So, since square root nga siya, so that is 7. Since ang square root ng 7 is 49. Thus, so yun yung conjecture natin. Sa letter B naman, if the length of a pendulum is quadruple, what happens to its period? So, sa table, ang pendulum with the length of 4 units has the twice of the pendulum with a length of 1 unit. So, a pendulum with a length of 16 units has a period that twice that of a pendulum with a length of 4 units. So dito naman, it appears that quadrupling the length of a pendulum doubles its period. Nagdodoble lang siya. So yun yung conjecture natin. Let's find a counterexample. So verify each of the following statements is a false statement by finding a counterexample. Sa letter A, let x be equals to 0. So magiging 0 greater than 0. Pero 0 is not greater than 0 naman. So we have found a counterexample. Thus for all numbers which is x is greater than 0 is a false statement. Let's proceed sa letter B. Let x, or supposed to be x, is equals to 1. Then we have 1 to the power of 2 is greater than 1. Pero since 1 is not greater than 1, we have found a counterexample. Thus, for all numbers x to the power of 2 greater than x is a false statement ulit. Sa letter C, consider x is equals to negative 3. Then magiging the square root of negative 3 to the power of 2 is equals to 3. Now, ang sagot niya is 3, but kaya maging 3 is not equal to since 3 is not equal to negative 3, we have found a counterexample. That's for all numbers that is the square root of x to the power of 2 is equals to x is a false statement. So lahat siya is counter-example, counter-argument. Ano daw? Okay, so that's all for my part. That is inductive reasoning. And the next reporter, Miss Hamsa, will be reporting the deductive reasoning. Thank you. Chair nagbaw!
Good day, everyone. Today I will be discuss the deductive reasoning in mathematics and what is it and why it is important and how do you use it in everyday life. So first, let's define the deductive reasoning. So deductive reasoning is a way of thinking where a form and conclusion based on the general principle or the rules. So, in simple terms, we use specific rules to arrive at the definite answer. So, for example, halimbawa, lahat ng tao ay may puso. So, halimbawa si Pedro ay isang tao. So, makakabuo tayo ng conclusion na si Pedro ay may puso. So, that is deductive reasoning. So, another example, deductive reasoning and mathematics. So, um, um, kung sa, balikan natin yung, kung yung nasa ano, so, kung saan pipili tayo ng isang number, pagkatapos ay susundan or susundin natin ang process upang malaman kung ano ang magiging result. So, um, this is the logical process. It's what makes mathematics. So, deductive reasoning and algebra. For example, from provided example, let number n be any number. So multiply by 8. So and next we will add natin sa 6. So 8n plus 6. So next we will be divided into 2. So 4n plus 3. So next we will subtract it into 3. So the final answer is 4n. So mapapansin natin na uh, kung ano man yung piliin natin na number, ang final result ay palaging nasa 4 times. So, that's the original number. So, okay, so next, I will discuss the comparison of inductive reasoning and deductive reasoning. So, and we will learn their difference and how we use them in our daily lives. So, um, examples, um, in a is a way or inductive reasoning is a way of reasoning we will use specific observations, for example, to form a general conclusion. So, example, in the past 10 years, so the tree in our backyards has produced a plum. So, every year siya. So, last year is hindi siya namunga because hindi siya namunga. So, ngayong taon na to is i-expect natin na mamunga ito. So, inductive reasoning is we don't have absolute certainty. It is based on the past or observation. So our conclusion may be right or wrong. So that is inductive reasoning. So the deductive reasoning is we start with a general principle or rule and used to form a specific conclusion. So example, all home improvement project costs than estimate. So the estimated that my house renovation would cost a $35,000. So therefore may yung house ko is ang renovation will definitely cost more than $35,000. So mapapansin nyo dito, yung conclusion niya is sigurado, and dahil ginamit natin yung um, um, isang tiyak na patakaran or prinsipyo. So, first is we will be start from specific examples. So, and create the general conclusion in inductive reasoning. So, the answer is not always certain in inductive reasoning, and also the observation to predict a possible result. So in inductive reasoning is we will start from a general principle and specific answer. So in inductive reasoning is the answer is always certain if the principle is correct. Now, so let's proceed to use a deductive reasoning to solve a logic puzzle. So um, there are situations. So there are four neighbors. We have Sean, Maria, Sarah, and Brian. So each of them has a different occupation. So they're editor, banker, chef, and dentist. So we have four clues. So to determine who has which job is Maria gets home after banker but before the dentist. So Sarah is the last to get home and is not the editor. So Sarah and the dentist leave for work at the same time. So the banker lives in the next door to the Brian. So to make it easier to find the answer, we will use a logic grid. So in this grid, we mark what is possible not or not possible for each person. So our first clue is Maria is not a banker or a dentist, since she gets home after the banker out a banker, but Maria or banker but before the dentist. So Mark is on the banker and the dentist for Maria. So our second clue is Sarah is the last to get home, so she cannot be the banker. So Sarah is not a banker. So our third clue is Sarah is the dentist. So she leaves for the work at the same time. So this means Sarah is not a dentist. So our fourth clue, the banker lives the next door to Brian. So this means Brian is not a banker. So Mark, um, so now we have enough information to determine that each person each person's correct job. So using our logic grid, we see that so Maria is the editor, Sarah is a chef, Sean is a banker, and Ryan is a dentist. So that's all. Um, I hope you understand how to use a deductive reasoning to solve a logic puzzle. So, and also that's all for my part. Thank you.
Good day everyone, and good day to you, sir. My name is Alizir Tomas Gehal, and I'm explaining to you what is my part, sequence. So what is sequence? So now, let's take a look at this number. 1, 3, 5, 7, and the 3 last number is missing. So this is called sequence. Sequence is an order list of number following a specific rule or pattern. Each number in a sequence is called term, and the sequence can be finite and infinite. Common types include arithmetic and geometric sequence. So now, let's take a look at our example. As you can see, the number 1 is the first term, the number 3 is our second term, while the 5 is our third term, and number 7 is our fourth term. The first space is our fifth term, the second space is our sixth term, and the last space is our seventh term, and the triple dots, that symbolizes our nth term. Its value or its term can be represented by a sub 1, a sub 2, a sub 3, 4, 5, 6, and 7. So if the term of a sequence increase, it may involve addition or multiplication. To know what is the common denominator, we have to subtract the second term to the first term. So 2. So 1 plus 2 is equals to 3. So that's why 3. Then 3 plus 2 is equals to 5. So that's why I circled the 5. And then 5 plus 2 is 7, so that's why I encircle the number 7. So 7 plus 2 is 9, so that's why I wrote the 9 on the first space. So 9 plus 2 is equals to 11, so that's why I put 11 on the second space, and the for the last space 11 plus 2 is equals to 13, so that's why I encircled 13. To simplify, just add the common denominator to the second term to get the next term. For our sample number 2, we have 2, 5, 8, 11, and 14, and the 9th term. So again, we have 2, 5, 8, 11, and 14. To know or to simplify what is denominator, we have to subtract the second term to the first term. So 5 minus 2 is equals to 3. So that's why 2 plus 3 is equals to 5. Then I wrote the number 3 to know the common denominator between 2 and 5 is 3. Then 5 plus 3 is equals to 8. So that's why again I wrote the number 3 to simplify or to know that the common denominator between the two numbers is 3. So that's why I put number 3. So 8 plus 3 is equals to 11. So I wrote the number 3 on the first term because it is the common denominator between the two numbers. Then 11 plus 3 is 14. So again, I just wrote again the number 3 at the first different to know that their common denominator is 3. To know the nth term, we just simplify, add the last sequence number, which is the 14, and also the common denominator, which is 3. So 14 plus 13 is equals to 17. So that's why I wrote 17 for to know that the nth term is 17. So that's our final answer, 17. Then now let's move forward to our third sample. and we have 5, 14, 27, 44, 65, and the ninth term. So to know what are those common difference between those numbers is we just have to subtract the first term to the second term. So 5 minus 14 is equals to 9. Then we have to subtract 2. 14 minus 27 is equals to 13. So the common denominator between 14 and 27 is 13. So now let's move forward to the third term, which is the 27 minus 44 is equals to 17. So the common denominator or common difference between the 27 and 44 is 17. So that's why I put number 17. Then we have to subtract 44 minus 65 is equals to 21. So the common difference between 44 and 65 is 21. So that's why I put 21 on the I wrote on the first difference. So 9, 13, 17, 21 are numbers that are not contrast. So not to another session. So 19 minus 13 is equals to 4. So the common denominator is 4. So 13 minus 17 is 4 again. Then 17 minus 21 is 4 again. So our second 21. So our second term is contrast because it's 4, 4, and 4. So the next to do is we are going to find what is the nth term. So just simplify. To know what is the nth term, we have to get the last term, which is 65 plus the common denominator between 44 and 65, which is 23. So 65 plus 21 is equals to 86. Then 86 plus the contrast number, which is 4. So 86 plus 4 is equals to 90. So that is our ninth term. So 4 came from the contrast number, and the 68 came from 65 plus 21. So that's why it's 86. So again, our final answer is 90. So in our final sample, it's different because it was shaped. And now we have to answer three questions, which is A, B, and C. So as you can see, the first term we have 2 blocks, and the second term we have the 5 blocks, and the third term we have 8 blocks, and then for the last term we have 11 blocks. So actually same lang siya sa number, but to know what is the common denominator, we simplify, subtract the second term to the first term, which is 2 minus 5 is equals to 3. Then 5 minus 8 is equals to 3. Then 8 minus 11 is equals to 3, and the ninth term. So we're going to find what is the nth term. Just take a look on arithmetic sequence, which is an is equals to a sub 1 plus n minus 1 d. Now that we have our arithmetic sequence must to follow, just copy an, and a1 or a sub 1 is our first term, which is 2. Then combine like term, which is 2 minus 3 is equals to 1, then times 3. And the answer for the first question is an is equals to 3n minus 1. So this is the final answer. B. How many tiles are in the 8th figure of the sequence? Then now we must follow the formula that we do on the number 1 question. So substituting n8. So copy a sub 8 is equals to 3 close and open parenthesis 8. Then 3 times 8 is equals to 24 minus 1. So it's 23. And for the final answer of our question number 2 is 23. For the final and last questions, which figure will consist of exactly 320 tiles? So let's answer number 3. We must follow the formula that we do on muna number one question. So 3n is equals to 321 kasi we have to add one both side to move one to the right. So ganito yan siya. So 3n minus 1 minus 320. So that's why naging 321 because add 1 both side to move 1 to the right. So n is equals to divided by 321 divided by so yan nga diyan nakuha yung 331 divided by 3. So 107. So that is our final answer, 107. Thank you for listening my report. Again, this is Alizir Tomas Gihal. Thank you for watching. Bye-bye.
Good day, everyone. I'm Nadine Hassan, and I'm gonna continue the topic from the group 3. Okay, so today's lesson is all about the Fibonacci sequence and some exercises from polygonal numbers. So now, let us tackle about the Fibonacci sequence. It says here, Leonardo of Pisa, also known as Fibonacci, in the year of 1170 to 1250, is one of the best-known mathematicians of medieval Europe. In the year of 1202, after a trip that took him to several Arab and Eastern countries, Fibonacci wrote the book Liber Abaci. So, in this book, Fibonacci explained why the Hindu-Arabic numeration system that he had learned about during his travel was a more sophisticated and efficient system than the Roman numeration system. This mathematician man named of Leonardo Pisano or aka Fibonacci kasi kilala siya as a Fibonacci, and he hailed from the Republic of Pisa, which is why he also known as Leonardo of Pisa. He is the most talented mathematician in Middle Age. So at that time, Europeans are still using the Roman numeral system, but in the Hindu and Arabic mathematicians, they are using a different numeral system, and which is a more robust and efficient way, and it is like fascinated brilliant of the Hindu and Arabic numeral system, and this Fibonacci brought them to the Western world in the year of 1202. That year, he wrote that book. The name of the book is Liber Abaci. So inside of Liber Abaci, he reviewed, he learned, he compared the Hindu and Arabic numeral system to the other system, such as the Roman numeral system, and he described how using the Hindu and Arabic system made. This book also contained a problem created by Fibonacci that concerned the birth rate of rabbit. So here is the statement of Fibonacci rabbit problem. At the beginning of a month, you are given a pair of newborn rabbit. After a month, the rabbit have produced no offspring. However, every month thereafter, the pair of rabbit produce another pair of rabbit. So in this slide, this is the statement. The Fibonacci create some problems. So the solution of this problem is a sequence of numbers that we now call the Fibonacci sequence. The following figure shows the numbers of pairs of rabbit on the first day of each of the 6th month. The larger rabbits represent mature rabbit that produce another pair rabbit each month. The numbers in the region is 1, 1, 2, 3, 5, 8 are the first 6 term of the Fibonacci sequence. So, ito yung statement na ginawa ni Fibonacci. Okay? So, here we have the pair of rabbit. Pag one pair, sa pag isa lang ang number, isang pair. Okay? Pag second month, isang pair of rabbit, you have 1. Yung naging 1 din nandoon. And then next, we have a pair of 2. Ang number sa gilid, equivalent na magiging dalawa din ang pair of rabbit din. And then next is we have number 3. Naging 3, it because you have to add first and a second of number by adding them. Siya naging 2 because you have to add it by the first and second number. So, makukuha mo. So, kung ano yung sagot, yung number 2, gi-add ng number 1, kaya naging 3. So, ganun lang siya yung month of the rabbit. Gi-add lang siya para makuha kung ilan ba every month na produce ng rabbit. So, it's like adding it na using the Fibonacci sequence until hanggang 8. Okay? Pag mag 3 plus 5 equals 8. So, dapat 8 pair dito sa statement na to. It says here, Fibonacci discovered that the number of pairs of rabbit for any month after the first 2 months can be determined by adding the number of pairs of rabbit in each of 2 previous months. For instance, the number of pairs of rabbit at the start of the 6th month is 3 plus 5 equals 8. We have here the Fibonacci number. We have the Fi equals to F1. We have F2 equal 1. And Fn equals to Fn minus 1 plus Fn minus 2 for n greater than 3. So here we have, sa baba niya pa is we have the formula of Fibonacci. We have Fn equals to Fn minus 1 plus Fn minus 2. Of here, some examples kung paano natin makuha ang Fibonacci numbers. Okay? So here, sabi dito, use the definition of Fibonacci numbers to find the 7th and 8th Fibonacci numbers. We have the example number 3. It says here, the first 6 Fibonacci numbers are 1, 1, 2, 3, 5, and 8. The 7th Fibonacci number is the sum of the 2 previous number. Thus, so ito. We have to first know the Fibonacci formula. Okay, so we know the Fibonacci formula. Formula is Fn equals to Fn minus 1 plus Fn minus 2. So, since ang given natin or hanapin natin yung number 7 or Fibonacci number 7 is yun yung maging given natin sa n. So, ilagay natin, palitan natin yung n sa 7. So, F7 equals to F7 minus 1 plus F7 minus 2. Okay? So, bring that down. Naging 7 minus 1 equals 6. And then, bring that, minus natin yung 7 minus 2 equals 5. Okay, so saan ba nanggaling ang 8 and 5? Dito siya nanggaling sa previous ng 6 Fibonacci numbers. We only have to count kung ano yung 6 Fibonacci number dito sa previous. So, since na-solve natin, na-minusan natin ang 7 minus 1, bibilangin natin ang 6 dito. So, we have 1, 2, 3, 4, 5, 6. So, pang 6 ang 8. So, ito yung pang 6 na Fibonacci number. So, lagay natin sa baba. Next is 5. Bilangin natin ang 5 dito. Okay? Kung saan ang 5. We have to find the 5 Fibonacci number here. So, we have to count 1, 2, 3, 4, 5. So, 5 din ang ang number niya dito since nahanap natin. So, i-bring down natin dito. Next, after natin malalaman kung saan dito ang number nila, we have to add it. Yung 8 plus 5 equals 13. So, 13 ang 7 Fibonacci number. 13. So, next we have the 8 Fibonacci number. Hanapin natin ang pang-8 na Fibonacci number. So, here, same lang din sa una. Kung paano natin hanapin, we have fn equals to fn minus 1 plus fn minus 2. And then, since ang given natin an 8, yan ang papalitan natin sa n. So, we have here f8 equals to f8 minus 1 plus f8 minus 2. So, i-minus lang natin sila. 8 minus 1 equals 7. 8 minus 2 equals 6. So, after dun, we have to count where is the pang 7 dito sa Fibonacci number. So, 1, 2, 3, 4, 5, 6, 7. So, pang 7 ang 13. Next, we have to count the 6 in here in the Fibonacci number. So, count tayo. 1, 2, 3, 4, 5, 6. So, pang 6 ang 8. After dun, we have to add it. So, 13 plus 8 equals to 21. So, ganun lang siya kadali hanapin ang Fibonacci numbers. Either na pwede din sa number 9, hanapin mo ang 9 na Fibonacci number niya. Number 10, number 11, number Fibonacci ay makikita kahit saan. Pwede through flowers, through snail, lahat makikita mo sa paligid mo ay it is include sila sa Fibonacci. So, we have here a Fibonacci number cropping up everywhere. So, we have here the other examples. The seeds on a sunflower are arranged in spiral that curve both clockwise and counterclockwise. From the center of the sunflower, head to its outer edge. In many sunflowers, the number of clockwise spirals and the number of counterclockwise spirals are consecutive Fibonacci numbers. For instance, in the sunflower, show at the left the number of clockwise spiral is 34 and the number of counterclockwise spiral is 55. So, it has been conjectured that the seeds on a sunflower grow in spiral that involve Fibonacci numbers because this arrangement form a uniform packing at any stage in the sunflower development. Its seeds packed so that they are not too crowded in the center out, not too sparse at the edge. So, ito yung sa picture na to, nakita sa baba, ito yung flower. Okay, sa other side, nakita nyo yung ganun yung example kung paano nakuha ang 34 and 55 sa doing clockwise and counterclockwise. So, it says here, nasa gitna, it says, the seeds on its sunflower from 34 clockwise spirals and 55 counterclockwise spirals. The numbers 34 and 55 are consecutive Fibonacci numbers. So, we have here other examples. We have, it says here, determine whether each of the following statement about Fibonacci numbers is true or false. So, note, the first item of the Fibonacci sequence are 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. So, we have here A. If n is even, then fn is an odd number. Number 2, it says here 2fn minus fn2 equals fn plus 1 n and greater than 3. Okay, so the answer here, the difference table for the number in the Fibonacci sequence does not contain a row of difference that all the same constant. So here are the solutions of the A and B. So number A, an examination of Fibonacci numbers shows the second Fibonacci number 1 is odd number, and the fourth Fibonacci number is 3 is odd, but the sixth number Fibonacci is 8 is even. Thus the statement, if n is even, then fn is an odd number, is a false. Nakadepende siya sa pag-a-adding. Kaya hindi siya even and odd, okay? It's false. So we have here sa B, experiment to see whether fn minus fn minus 2 equals to fn plus 1 for several value for n. For instance, for n, 7 we get. So, 7 dito yung given. Kumbaga yung n, yung hanapin. Okay? Hanapin siya. 2 fn minus fn minus 2 equals to fn plus 1. Next, next we have 2 f7. Ang 7 galing sa given. So, minus f7 minus 2 equals to f7 plus 1. So, next, ang ginawa natin, okay, bring pa sa baba is 2f7 minus, giminusan natin, 7 minus 2 equals 5, equals to, naging 8, para naging 8, gi-plus lang natin, 7 plus 1 equals 8. Sa baba naman, paano naging 13? Okay? Ang 13 na to galing sa Fibonacci numbers. Yan yung ginawa natin. Paano natin malalaman kung ano yung Fibonacci numbers ng 7? So, it's 13, di ba? Kasi ang 6 is 8. So, 13 ang pag 7. Kaya naging 7 dito. So, Fibonacci number 8. Paano natin ginawa natin nung last, di ba? Hinanapan natin kung ano yung Fibonacci number 8. So, ang Fibonacci number 8, yung 21. Kaya 21 siya dyan. Next baba, 26. Times natin. 13 times 2 equals 26. And then, minus 5 equals to 21. Next, we have here, 26 minus 5 equals 21, then 21 equals to 21. Equal na sila ang answer nila. So, after natin na-solve, it says here, which is true, evaluating 2fn minus 2 for several addition value for n is greater than 3. We find that in each case, 2fn minus 2 equals to fn plus 1. Thus, by inductive reasoning, we conjecture 2fn minus 2 equals to fn plus 1 for greater than 3 is a true statement. So, mas totoo po ito kaysa sa isa.
This is Alizir Tomas Gihal again, and I'm going to explain to you guys what is polygonal numbers. The polygonal number is a number that can be presented as a pattern of equally spaced dots arranged in the shape of a regular polygon. This number must follow specific formulas based on the number of sides of the polygonal. But we have three major samples of polygonal number: the triangular number, square number, and pentagonal number. A triangular number is a number that forms a triangular pattern with dots. It's the sum of the first and natural number and follow the formula. While the square number is a number that can be arranged in a square shape using dot, it is product of integer multiplied by itself. Pentagonal number is a number that can be arranged in a shape of a pentagonal using dots. These numbers follow a specific formula and grow in a pattern similar to triangular and square numbers.
So here we have the exercise from polygonal numbers. Kinuha ko lang to based lang sa book. Okay? In the polygonal numbers, kasama doon. So we have here in exercise 7 to 10, use the given nth term formula to compute the first 5 term of the sequence. So, ito yung mga formula. We have number 7, number 8, number 9, and number 10. So, itong formula to is sabi dito, hahanapin natin kung ano yung ibigay natin yung 5 terms ng sequence nila. So, we have to solve 5. Okay? 5 every formula. So, we have here number 7. So, we have an equals to n open parenthesis 2n then plus 1 close parenthesis divide of 2. So, we have here the first ano natin, actually is palitan mo lang ng number yung n, number 1, number 2, number 3, and 4 and 5. So, we have to solve it. Hanapin natin yung 5 term. So, mag-solve lang po tayo ng maka 5. So, palitan nyo. And after papalitan, isa-solve nyo. Paano nyo isa-solve? Ita-times nyo muna sa 2 times 1. We have here 2 times 1. And then, kung anong sagot, i-plus sa 1. After nun, i-times sa 1. Kung ano yung sagot, i-divide sa 2. So, ang sagot dito is cannot be divide kasi 3 siya ang sagot. Tapos, i-divide sa 2. So, it cannot be. It's either 3 divide 2 yung answer niya, yun na yun, or 1.5. Yun na yung sagot na. So, next, we have here the number 2. Here, the 2. Pinalitan lang natin. We have 2 times 2 equals 4, diba? So, i-plus nyo yan sa 1, naging 5. And then, yung 5, i-times sa 2, naging 10. Kaya dito, 10 divide by 2 equals 5. So, nakaya naman, diba? Nakaya ang pag-divide. So, hindi siya like parang sa number 1. Dito next sa number 3. We have here, 2 times 3 equals to 2 times 3 equals 6 plus 1, 7. Then, 7 times 3 equals 21. So, 21 divide 2 cannot be siya. So, kaya naging 21 divide 2 lang siya or 10.5. Yun ang sagot. It's either sa dalawa. Yun na yung sagot. So on. Meron dito number 4 and number 5. Ganun lang siya gawin. Papalitan nyo lang ng number, i-times, i-plus, i-times, i-divide. Kung ano yung sagot yun. Pero if cannot be siya, 2 traces. Yun ang answer. So next we have number 8. We have the formula of number 8. An equals to n divided by open parenthesis n plus 1 close parenthesis. So here we have the first. Parang sa una lang din. Lahat ng n, makikita nyo yung n. Papalitan nyo lang ng number. Okay? Just follow the solution. Follow the steps kung paano i-solve. We have here 1 times i-times siya. So, 1 plus 1. Okay? 1 plus 1 equals to 2. So, 2 divided by 1 equals 2. So, yun ang sagot. Next, we have number, we have A2, number 2. Ipapalitan nyo lang ng number yan. So, we have 2 plus 1 equals 3. And then, 3 divided by 2 cannot be, diba? So, we have to give the 3 divide 2 equals 2. Divide 2. Kasi cannot be siya eh. Cannot be siya parang sa una eh. So, maging 1.5. So, yan na lang ang answer. So, next, we have 3. Pinalitan lang natin. 3 plus 1 equals 4. 4 divide 3. Cannot be din. Hindi makaya, diba? So, answer niya is 4 divide 3 or pwede naman 1.5. Okay. And so on, so forth. Ganun lang. Pareho lang din. Papalitan nyo lang yung n ng number ng correct number po siya. So, we have the number 9. Here is the formula of number 9. An equals to 5n square root of 2 minus 3n. So, ulitin din natin. Okay? Yung n, papalitan lang natin ng numbers ng 1, 2, 3, 4, and 5. So, we have here number 1. Yung 1 siya. Pinalitan natin lahat ng n, ng numbers. So, we have First, i-times natin yung 1. 1 times 2. Okay. So, 1 times 1 equals 1. So, 5 times 1 equals 5. Okay? Binaba. Next, we have the 3 times 1 equals to 3. Next, we have to minus it. 5 minus 3 equals to 2. Next, we have number 2. Pinalitan lang natin ang mga n. So, next, we have first, we have to times it. 2 square root of 2 equals to 4. So, 4 times 5 equals 20. Bring down. 3 times 2 equals 6. So, bring down. So, 20 minus 6 equals to 14. Kaya ito yung sagot ng 14. And so on and so forth. Pareho lang din kung nakikita nyo. Pareho lang. Papalitan nyo lang. Ita-times, i-minus, sunod-sunod nyo lang. So, next, we have number 10. Lastly, number 10. Sa number 10, meron, ang formula ng number 10 is an equals to 2n square root of 3 minus n square root of 2. So, we have here number 1. We have 1 square root of 3 equals to 1. 1 times 1 equals 1. So, 1 times 2 equals 2. So, you bring down. Next is 1 times by itself equals to 1. So, 2 minus 1 equals 1. Next, we have number 2. And then, we have first, we have to times the square root of 3. 2 times square root of 3. We have the answer. After ng square root mo, ita-times mo din ng 2 equals to 16. Next, 2 times 2 by itself equals 4. So, 16 minus 4 equals 12. So, ganun lang po siya gawin and so on and so forth. Makikita nyo naman sa screen kung ano yung kasunod-sunod niya. Ita-times nyo lang after nang hanapin nyo ng square root of 3. Ita-times nyo yan sa number sa kasunod niya, yung 2. After nun, ibaba. Next is ita-times yung number by square root of 2. Kung anong sagot, ibaba and then i-minus. After minus, yun yung final sagot.
So now let's move forward for this sample. So as you can see on the first term, we have 1 block. For the second term, we have 5 block. But is considered as 5 blocks since squares number is structured pattern of a square number. So the excess is not counted. So the third term is 9, while the fourth term is 16, and the last term is the 25 and nth term. What is nth term? The first step we're going to do is find the common denominator. So subtract the first term to the second term, or second term to the first term. So 4 minus 1 is equals to 3. 4 minus 9 is equals to negative 5. 9 minus 16 is equals to negative 7, and 16 minus 25 is equals to negative 9. So basically, based on our first different number, it is not contrast. So we have to find our second number to see if it contrasts or it is not. The next step is we're going to subtract the second term to the first term. 5 minus 3 is equals to 2. Then 5 minus 7 is equals to 2. Then 9 minus 7 is equals to 2. So based on the result, the second different number is contrast. So now we can finally say that is contrast. And also we can use this formula for easy solving. And now let's move forward for the next sample. So we have here for the first term we have 3, and for the second term we have 6, for the third term we have 9, for the fourth term we have 12, and for the last term we have 15. So why all of this is not counted? So Basically, it is not counted because it is not following the structured pattern of square. So that's why it is not counted. Then we have to find what is the common denominator of each term. So 6 minus 3 is equals to 3. Then 6 minus 9 is also equals to 3. Then 9 minus 12 is equals to 3. Then 15 or 12 minus 15 is equals to 3. So basically, it is contrast. Then if it contrasts, it is okay. Then it is very clear that this problem is following the arithmetic sequence rule or the formula. So it is basically very simple because it is already contrast. So that's all, and thank you.
Assalamualaikum and good day to each and everyone, and especially to you, sir. I am Zeni S. Nindu, and our topic for today, it's about the mathematical prodigy. When you say mathematical prodigy, is an individual who demonstrates exceptional mathematical abilities of a very young age. So let's proceed to Carl Friedrich Gauss, 1887 to 1985. Was a scientist and mathematician. His work encompassed several disciplines including number theory, analysis, astronomy, and optics. And when you say number theory, it is a branch of mathematics that studies the properties of integers, which are whole numbers. Like for example, 1, 2, 3, -1, and -2, and etc. And when you say the analysis naman, it is a branch of mathematics that deals with the rigorous study of functions, limits, continuity, derivatives, integrals, and infinite series. Like for example, is x equal x squared. So, yun yung sa analysis. And when you say sa astronomy, it is the study of celestial objects, their positions, movements, and the physical processes that govern them. And lastly is optics. When you say optics, the study of light and its behavior, including its reflections, refractions, diffraction, and polarization. Another definition of Carl Friedrich Gauss, he is known for having shown mathematical prowess as early as age 3. It is reported that soon after Gauss entered elementary school, his teacher assigned the problem of finding the sum of the first 100 natural numbers. So, Gauss was able to determine the sum in a matter of a few seconds. So, this is the following solution shows the thought process he used. So, let's continue to understand the problem. The sum of the first 100 natural numbers is presented by 1 plus 2 plus 3 plus ... and plus 98 plus 99 plus 100. Another one is to devise a plan. Adding the first 100 natural numbers from left to right will be time consuming. Gauss considered another method. He added 1 and 100 to produce 101. He noticed the 2 and 99 have a sum of 101, and the 3 and 98 have a sum of 101. So choose the 100 numbers called be thought of as 50 pairs, each with a sum of 101. And another is to carry out the plan. To find the sum of the 50 pairs, each with a sum of 101. Gus computed 50 to 101 and arrived of 500,050 pesos as the solution. So to review the solutions, because the addition problem can be placed in any order without changing the sum. Gus was confident that he had the correct solution. Another for an extension, the sum 1 plus 2 plus 3 plus, and then plus, and close parentheses to and negative 2 plus close parentheses to and negative 1 plus n can be found by using the following formula. So this is the formula. So another formula is a summation formula for the first n natural numbers is to 1 plus 2 plus 3 plus dot 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 plus close and open parentheses and negative 2 plus open close parentheses and negative 1 plus and equal to the end close parentheses and plus 1 and divided by 2, and this the summation formula. So this is the sum example, which is the problem is what is the next number in the sequence 1, 4, 9, 16. So the solution is this sequence represent the squares of consecutive integers, which is 1, 2 equal 1 and 2, 2 equal 4 and 3, 2 equal 9 and 4, 2 equal 16. And so therefore, the next number is 5, 2 is equal to 25. A prodigy might not only identify the pattern but also generalize it to describe the n terms as n2. So this is the example po, and that's all po for my part. Thank you very much po.
Good morning. I am Kate IZV Kawit and I am going to tackle about the problem solving strategies. In this section, I will discuss the problem strategy focusing on George Polya's approach. Polya was a mathematician who studied how people solve problems and developed a structured method to help students and researchers approach problem solving systematically. Polya's problem-solving strategies. The text explains that ancient mathematicians were interested not just in solving problems, but also in understanding the methods behind discovery. Over time, different philosophers and mathematicians explored ways to develop universal problem-solving techniques. One of the most influential figures in this area was George Polya, who developed a simple yet effective four-step strategy for solving problems. The basic problem-solving strategy that Polya advocated consisted of the following four steps: understand the problem, devise a plan, carry out the plan, and review the solution. Polya's four steps are deceptively simple to become a good problem solver. It helps to maintain each of these steps and determine what is involved. I will provide a detailed explanation of Polya's four-step problem solving strategy by breaking down each step with practical questions and techniques. First is understand the problem. Before solving a problem, you need to clearly understand what is being asked. Some key questions to ask yourself include: can you restate the problem in your own words? Can you determine what is known about these types of problems? Is there missing information that, if known, would allow you to solve the problem? Is there extraneous information that is not needed to solve the problem? What is the goal? Next is devise a plan. Once the problem is understood, the next step is to come up with a strategy to solve it. Some useful techniques include: make a list of the known information, make a list of information that is needed, draw a diagram, make an organized list that shows all the possibilities, make a table or chart, work backwards, try to solve a similar but simpler problem, look for a pattern, write an equation. If necessary, define what catch variable represents, perform an experiment, and guess at the solution and then check your result. Next is carry out the plan. After choosing a strategy, it's time to execute it. While doing so, work carefully, keep an accurate and neat record of all your attempts. Realize that some of your initial plans will not work, that you may have to devise another plan or modify your existing plan. So, this step requires patience and accuracy to ensure the solution is reached correctly. Next is review the solution. Once a solution is found, it's important to check if it makes sense. This involves verifying that the answer is consistent with the problem, interpreting the result to see if it answers the original question correctly, considering if by approach use can be applied to other similar problems. By reviewing the solution, you confirm its correctness and improve problem-solving skills for future problems. This structured approach helps in breaking down complex problems into manageable steps, making problem solving more effective and systematic. Okay, for example, a baseball team won 2 out of their last 4 games. In how many different orders could they have 2 wins and 2 losses in 4 games? Okay, so we are going to use the Polya strategy. First is understand the problem. The team played 4 games and won exactly 2. The order of wins and losses matters, meaning different sequences must be considered. Possible sequences include winning 2 games first, then losing the next 2, or losing 2 games first, then winning the next 2, alternating between wins and lose. Second is devise a plan. To systematically count all the valid orders without missing any or counting duplicates, an organized list will be created. This method ensures each possibility is listed exactly once. Next is carry out the plan. Using a structured approach, the possible orders will be win-win, 2 wins, and 2 lose. Start with 2 wins. Win-lose, win-lose. Win, then lose, lose-win. Lose, then win, win, and lose. Lose, win, or lose-win. Lose, lose, or win-win. Each sequence contains exactly 2 wins and 2 lose, ensuring no possibility is missed or repeated. Last is to review the solution. By verifying the list, we confirm that all possibilities are covered and there are no duplicates. Therefore, the total number of different ways the team could have won 2 out of 4 games is 6. Okay, so let's proceed to routes on a probability demonstrator. The Galton board, also called a probability demonstrator, is a tool that visually explains probability, binomial distribution, and normal curve. Okay, so this is how the Galton board works. A ball is dropped from the top point A and moves downward through a grid of hexagonal pegs. At each peg, the ball has an equal chance of moving left or right. Since each ball takes a random path, the number of ways it can reach a particular bin at the bottom determines how many balls land there. The bins in the center have more possible paths leading to them, so they collect the most balls. This forms a bell curve or normal distribution. That's all for my part. Thank you for listening.